Now, many of these vector overlay geoprocessing tools will split and merge the input feature geometry, and you need to understand the effect this will have on the corresponding attribute values. When you update the feature geometry, the behavior of the attributes depends on whether it's a geodatabase feature class or a shapefile. If it's a geodatabase feature class, then the geometry fields are automatically updated, but not user-created fields. If you look at the image on your right, you can see the feature class attribute table includes the geometry fields shape length and shape area, and those fields are automatically updated if the geometry is altered, but not the user-created fields like SQFT. I would have to recalculate the square feet for the SQFT field if the geometry was altered. Now in shapefiles, the geometry and user-created fields are not updated if the underlying geometry is changed. If you look at the example on the right again, in the shapefile attribute table, it includes a shape length and a shape area field that was created when the original shapefile was created. But if the underlying geometry is altered, the shape length and shape area, as well as the user-created fields like SQFT, are not updated. You need to be aware of that and recalculate those fields if you're going to use them for your analysis. Now, there are also some attribute and domain properties that you can set that control attribute value behavior when you split and merge feature geometry. And so these policies for split and merge can be preset in the attribute domain. And if you look at the attribute domain properties window, you can see that for the split policy, that includes options for default, duplicate, and geometry ratio. And for merge policy, it's area weighted default and some values. And so let's take a closer look at these two policies and how they affect attribute values. When features are split, the split policy controls how attribute values are split from the input features to the output features. And there's three options in the split policy, and that includes default, duplicate, and geometry ratio. Default simply takes on the default attribute value that is set for that domain. If the duplicate policy is selected, features take on the copy of the original feature's attribute value. And if geometry ratio policy is selected, feature's numeric attribute value is calculated based on the ratio in which the original geometry is divided. And if you look at the image on the right, you can see I have three different fields and values: area, property tax, and owner for an individual parcel. And if I split that parcel and I have the policy set in the attribute domain, then the attributes are split based on that split policy. So for the area field, the property of the geometry is just split based on the portion of the geometry that's split. So in this case, 45% is allocated to one record and 55% of the area is allocated to the second record. If my split policy is geometry ratio, like I have assigned to the property tax field, then the property tax is split based on the ratio of geometry. So in this case, 45% of $2,500 in taxes is allocated to one parcel, and 55% of $2,500 is allocated to the second parcel. And last, the duplicate policy just takes the value from the original feature and assigns it to any features resulting from the split. So in this case, the owner was Bob Smith. The policy is duplicate. So the two new parcels are also assigned owner Bob Smith. When you merge features, the merge policy controls how you merge the attribute values from the input features to the output features. And again, we have three options for the policy: default, sum, and geometry weighted. Default is when the features take on the default attribute value. Sum is when the feature's numeric attribute is the sum of the original feature's attribute values. And last, geometry weighted is when the feature's numeric attribute value is calculated based on the weighted values of the original geometry. So again, if we look over on the right, we can see that we have three different fields: area, property tax owner, and two different features that are merged into a single feature. So for the area field, it's just a property of the geometry. So it calculates the new area, which in this case just combines the area from the two parcels into the merged parcel. The merge policy for property tax is set to addition. So it just adds the two values together and assigns the property tax to the merged value. And for the owner, it's just set to default value. So instead of Mary Jones or Bob Smith, it just defaults back to whatever the default value for that domain is. In this case, it's assigned to city. The last geoprocessing tools I want to speak about are the pairwise overlay tools, which maximize performance and accuracy when processing large data sets. Now, the classic overlay and the pairwise overlay tools are very similar, and both tools are often acceptable. But if you're going to have a very large and complex data set, you want to use the pairwise overlay tools. If you look at the image on the right in the geoprocessing pane in the analysis toolbox, you can see both an overlay toolset and a pairwise overlay toolset. And you'll notice that a bunch of the geoprocessing tools are similar. For example, I have the intersect tool open as well as the pairwise intersect tool, and they look very similar. And matter of fact, the intersect tool even has a message at the top that says the pairwise intersect tool provides enhanced functionality or performance. So when would you use one and when would you use the other? Well, it just depends. If you have a small data set, you can use either. But if you have a very large and complex data set, then you're going to want to use the pairwise overlay tool. So if you're just going to buffer one feature, then just use the buffer tool. But if you're going to buffer thousands of features, use the pairwise buffer tool. Now let's review by comparing vector proximity analysis to vector overlay analysis. What's near what versus what's on top of what. Vector proximity queries select features where the boundaries touch or within a distance. Vector overlay queries select features that intersect, features that contain other features, features that are within other features, or features that are identical. Vector proximity analysis creates a new output with features that are adjacent, nearby, or within a distance. Vector overlay analysis creates new clipped, erased, combined, or aggregated features. Now, while there are a lot of different applications for overlay querying analysis, a common way to use overlay analysis is to model how geographic phenomena affect each other via an impact assessment, where we're answering questions like, how will a Category 5 hurricane affect a large coastal city? Is contaminated groundwater a threat to nearby neighborhoods? And how do established archaeology sites impact a planned highway route? Now, again, we can use the standardized analytical process, question, inform, analyze, decide, and present to frame our impact assessment process, where first, we need to establish the question and identify the model and change agent. And then we need to inform our analysis by identifying and model the entities impacted by the change agent. Next, we need to perform our analysis, where we analyze the impact of change. Then we decide and refine our analysis based on our findings. And last, we present our analysis by quantifying and visualizing the impacts. Our objective has been to create accurate vector GIS data through overlay analysis. And at this point, you should be able to describe different vector overlay spatial relationships, including intersects, contains, within, and identical. Distinguish between vector overlay query and analysis. Overlay query allows you to overlay layers and select features based on their spatial relationship. Vector overlay analysis actually creates new data based on their spatial relationship. You should be able to list and describe different vector overlay geoprocessing tools like erase, union, or spatial join. You should be able to compare vector proximity versus overlay analysis. Vector proximity models what's near what, and vector overlay analysis models what's on top of what. And last, you'll use vector overlay tools to perform an impact assessment both in the lecture demo and the project.